In this video, we're going to take a look at log signing in EventSentry that gives us the ability to digitally sign both event logs and syslogs in EventSentry. Log signing is separate from the database and is handled on a file system level, meaning that you'll have to set up a file action that writes all event log and or syslog data to a text file, which is then in turn digitally signed by OpenSSL. Let's just review real quickly why we would be doing log signing, what the benefits are and what the limitations are. A lot of times the requirement for log signing comes from compliance, but it's also helpful in a situation where you have a large team of sysadmins and you want to make sure that the person administering EventSentry does not have the ability to modify or delete logs, for example. When you utilize log signing EventSentry, that it will protect the logs from tampering, not only by signing the logs, but also by timestamping them. That means that even if the system administrator has access to the private key to actually re-sign potentially modified logs, timestamping will prove when the file was signed. So if you're looking at a file from October 1st and it was signed on October 15th, then you can assume that this log or this text file or this log has been modified. So if, for example, you're reviewing a log from October 1st and you want to make sure that it hasn't been tampered with and it matches the signature, however, it shows that the log was signed or timestamped on October 15th, then you can assume that this log has been tampered with, that it was re-signed, because under normal circumstances, that log file should have been signed pretty much the same minute that it was generated or hour, and not 2 weeks later. Now, basic log signing, and that's how I'm going to demonstrate this on this test machine, can of course be done by storing the logs on the same server where EventSentry is running. But in most cases, we'll recommend storing the logs on a different machine, ideally a machine that the EventSentry administrator does not have access to, or only has write access to, meaning the ability to add files and not to modify them. And if you want to take it a step further, then you can utilize some sort of a NAS system that supports warm media, meaning write once, read many, where the actual file system is implemented in a way that nobody can modify files, meaning a file is created and that's the extent of it. You can't delete it and you can't change it. So this is an additional protection in addition to the actual log signing. Log signing is done in EventSentry with the file action. And I've created 2 file actions already just to save us a little bit of time. So if you go down here under actions, we'll see 2 file actions. One called event logs that I'm using to store event logs in the file system. And the other one, syslogs, that I'm going to use to write syslogs to the file system. I've actually modified the path, so I'm now writing to the F drive, not the E drive. So I'm going to just change this here real quick. And you'll notice that both of these actions have a initialize button. And that's because log signing does require you to create 2 keys, a public and a private key. The private key signs the files, the public key verifies them. It doesn't matter which one we choose here, so I'm just going to click initialize here. It's going to say it's creating the public and private keys, and it's downloading the timestamping certificates. This usually takes a few seconds. So we're going to just say yes here. And we have a confirmation, log signing was set up successfully. So now we'll see if we go to these actions, that button is no longer there. How does this work in the back end? I'm here in the installation directory, and there is a log signing directory. And here are the 2 keys. We have a private and a public key that, if you look at the timestamp, were just created. And we also have the timestamping certificates that were downloaded from the free TSA website that allows for free timestamping. The logs are signed using OpenSSL, and we ship a very light version of OpenSSL. If you look at resources here, you'll see there's an OpenSSL folder now with a bunch of, with 1 executable. So that's how they are signed. And the actual scripts are in the scripts log signing directory, where we have 4 scripts. And the only one that you should be needing is the log verify script, but we'll get to that later. This is all, of course, available to be edited. So, for example, if you wanted to use a different timestamping service, then that could be changed. But let's finish setting up these actions here. So what we're doing here is we're providing a path where these files are logged. Again, I recommend that you to write this to a different server to which the EventSentry administrator does not have access to, but in our case, it does already provide some protection due to the timestamping of the logs. We're not just signing them, we're also timestamping them. Here, we are creating a separate log file every minute of the day. So we're creating a log path here, a file path with the year, the month, and the day. So it's going to be easy to understand. And then we're creating the actual files as well that have year, month, day, hour, and minute. So every minute, assuming a log is generated, a new log file is going to be created. And this looks exactly the same on the Syslog side, except that here we have syslog underscore to kind of distinguish. Of course, this could be a different log path too. But again, this is just for demonstration purposes. I'm going to check digitally signed files here. And now how can we actually divert data there? Because those are just actions. Nothing's going to happen if they're not referenced. So two things. On the network services now in version 6, you can actually add a text file action here. So previously only databases were supported, but now we can add a text file. So the file actions, so now we have syslog here in the list. And for the EventSentry logs, we're going to go to the database consolidation package. And here we have 3 filters that send data to the database normally. And we're going to just piggyback on that. And we're going to say, well, let's consolidate. Let's write these here as well, non-security events. So that's anything that's not security. But we're going to write security events here as well. So we're going to use this for everything. And audit success, the same thing. I'm going to save and deploy this. And another thing to point out, of course, is, and that's already enabled here, that's very important, both of these actions will need to be enabled. It needs to be configured to use the collector. So this log signing feature only works with the collector, since the logs are signed centrally, and we don't want to be sending and storing the public and private or the private key on every agent. So it's important that this use collector here is enabled. Let's take a quick look at the flow of log signing, how this works in EventSentry. So on the top left, we see the event logs. So those are being sent to the collector, to the file action in the collector, which in turn creates the event log text files that contain that event log data. Once the file is complete, the collector triggers the log sign CMD. So this is sort of built into EventSentry, right? This cannot be changed. That log signing script does utilize the private key. I didn't mention this earlier, but the private key needs to, of course, be kept securely. Now, we always have the timestamping that will always tell us when the file was signed. So that is a very important part of the whole integrity and security of the system. Nevertheless, the private key should never be shared, and ideally only the collector should have access to that private key. Now, once that log signing script runs, it will first create the signature file. So that's the actual digital signature of the event log text file. And it will then go to the timestamping authority and create the TSR file, at which point the file is digitally signed and timestamped. Now, to verify the file, we need the public key. We do not need the private key, of course, so the public key could be copied onto a different system. For this, we have the log verify script that will use the public key to verify the signature, and it will also verify the timestamp. Digital signature, that's in the .sig file, was verified. The script will say the signature is okay. And it will also show us, assuming that the timestamping signature is okay as well, when the file was signed. So now that we've enabled the log signing, let's take a look here. I'm back here in the folder where we're storing all these logs. So 20, that's today, and that's the hour, so that's 10 p.m. And we can already see a number of files in there. And if you look closely, we'll see, of course, the year, the month, the day, the hour, and then the minute. And for every minute, we have 4 files. So the first one here, and the same applies to Syslog, by the way. So it just says Syslog here. So if we open that file, it's 200 kilobytes big. We're going to go with this one. And what we see here is we see all the events that were written in that 1 minute. Now, again, this is separate from the database, and this is really not intended to be used for any type of reporting. So the purpose here is really once you've singled out a specific event that you want to verify, so let's just say something critical happened at 10, 11 p.m. on this very day, then you can go into this folder. You can find the event or the events in these files, and then once you found them, you can go in and actually start verifying, okay, does the digital signature actually match? And there's 3 additional files that we can see in there. The first one is the actual digital signature. This one is a timestamping request file, a query file, and this is the timestamping response. So we'll need all 3 of these additional files for the signature to be considered complete. So those should not be deleted. And if we see, so things are happening here in real time, and you'll see here that the file number 16, so we are at minute 16, so right now, and we can see how the file size is changing. So the file is being created, and as soon as the file is finished being created, it's going to get digitally signed. And the same applies, of course, to Syslog. So while the file is being created, and we're going to just fast forward over this, nothing will happen. It will just write the file, and once it's completed and a new file is being generated, which would be number 17, only then will the signing actually start using OpenSSL. And here they are. As soon as the new file was generated, these other files here were digitally signed. Now, it's not necessary to create a new file every minute. The file name can be changed in the minute. The $minute variable here could be removed. And then a new file will be generated every hour. So if you have a very low volume of logs, then that would be an option. But in most cases, there should be activity every minute, and I would prefer and I recommend going with the default, which would be the day, hour, and minute file name here. So I think this is pretty straightforward up to now. We create the actions, we reference the actions, of course, and then we just kind of confirm that the files have been created, that we get those signature files. But now, how do we validate those signatures? How can we actually verify that these files, that the signature for these files is actually accurate? So for that, we'll have to open up a command prompt, and we'll go to the EventSentry installation directory here under log signing here. And that's where we have those 4 scripts, and we will need the log verify.cmd version of this file. And here we simply reference the actual log file. So let's just start maybe with the first one we have on the list here, right? This one here. So we can just copy the whole path here. I don't need to use quotes because there are no spaces here. And it goes to the first one. Well, actually, we want number 14, but it actually doesn't really matter. So we can actually go up to the very top here. So this is the first one. Let's just start with that one. And here it ran. It says the signature verification is okay. The timestamp verification is okay as well. And here we want to make sure that we check the timestamp. So that's really the most critical thing. And keep in mind, this is GMT, right? So this is 6 hours ahead of us. So this is, here we are December 20th at 10 p.m. So GMT would be 6 hours ahead of us. But we can see, right, that this was timestamped at 09, so 1309. So the minute is actually one more, of course, because this file was finished writing at 12:59. So at 13, the new file was being generated. So in this particular case, it seems to have taken 9 seconds for it to be assigned, or the time on this server is a few seconds off. So that would be another explanation. So for example, we can now go to number 13 and just verify that one and see what happens. And here again, we can see that it was signed at 58. So again, a couple seconds off here, most likely because of a time difference with this server, because it's synced differently than at Free Timestamping Authority. But as long as we're just a few seconds off, that is really not an issue. Nobody would be modifying or re-signing the log file immediately. That doesn't make any sense. And as I mentioned earlier, it's definitely recommended to store this on a different machine, ideally on a warm media where you can't modify the files in the first place. Now, for those who are interested, I'm going to go in and I'm actually going to modify one of these log files, and I'm going to re-sign them and kind of show what that would look like. So I'm going to pick this one here. Actually, I'm going to pick this one here, 17. We're a little bit ahead of this already. Current time here, we're at 22. So I'm going to open this here, and I'm just going to randomly go in here, and I'm just going to go in and delete a few entries here. Save it. Because I'm the admin on this machine, I can save this file. So first, before we do anything else, we're going to go to 17. I'm going to run it, and it immediately tells us that the signature verification failed. All right, so that's good. But now I'm going to go in and say, you know what? I'm going to sign this file again. I'm going to use that same file name. And yeah, the file has been signed again. Great. So now I modified the log. It's signed again. If anybody ever comes back in to check it, it will say it's signed. No problem. However, we can already see here that the timestamp is now different. So if I go back up here and do a log verify, it will of course pass because the file has been signed. However, we know that this file was generated at 17, so 10/17. And of course, we can open up the file and verify that the log entries are actually from 17, which they are. But we can see here that the file was signed at 23. So that is 6 minutes later. So that would already tell us that something is off. Of course, in the real world, you would see a vastly different date here. So, you know, if somebody were to go in and change a log entry from a month ago, then the timestamp would be way off. And it would be immediately obvious that this file, even though it is signed, has been was signed at the wrong time, was signed days or weeks or months later. And so that would be the indicator that something is off. And again, this works completely separately from the web reports. This does not affect the web reports. Everything works as always. There's no performance hit on that end. It just essentially creates this second log repository that is protected with digital signing. As always, thanks for watching.